Again, just so we're clear, this word tangent, it's not the same meaning as we just learned about in trigonometry, where it's opposite over adjacent. That has a different meaning here. A line is tangent to a circle if that line just touches the outer edge of a circle like this. This is called a tangent line. There's one point right here where the line touches the circle. The key word there being one point. Normally, if you think about a line going through a circle, imagine this in your head for a second. Imagine a circle and a line going through it. How many times does a line touch the circle?
Twice.
Twice, right? That's not a tangent line. A tangent line is a line that touches a circle only once on the outside.
So what's the one that goes through a circle?
A secant line. None of these are. These are only tangent lines. So draw that. And then draw that, label it point of tangency. That's where the line touches the circle.
Oh, what are you doing? Wait, do you want to see erase that circle that line?
I want to do erase it there. You can leave it on there. I'm gonna put it back on in a second.
Why'd you erase it?
So I can explain where it comes from. Who could tell me what a radius is of a circle? I know a lot of you probably could. Be brave. What's a radius? Half the diameter. Good. Somebody said something over here. Megan, what were you saying? Starting from the center to the edge, right? That's a radius, yeah? So we're talking about a lot of things involving a radius and a point of tangency. We ready to move on? You guys got this drawn? All right. Here's a theorem. It doesn't have a fancy name. We should come up with a name for it. Somebody name this theorem.
Tangent theorem.
The tangent line theorem. The Michael theorem. I'm kind of hungry right now, so let's name it something with food.
Hungarian theorem. On your face theorem.
The Hungarian?
Off the wall theorem.
It's just called theorem.
Carl's theorem.
Carl's Jr. theorem.
No, we'll call it bacon burger. We'll call it CJ theorem.
CJ.
Because a bacon burger is round, so.
That's true. Bacon.
And then the bacon strips go through like a diameter from the radius.
The bacon strips are the diameter.
Yeah.
You guys are thinking, all right, this is the double Western bacon cheeseburger theorem.
It's your fault that we get distracted. Double Western.
If a line is tangent to a circle, let's stop here. What does it mean for a line to be tangent to a circle? Touching it only on the outer edge at one point. That's what it means for a line to be tangent. So if a line is tangent to a circle, oh boy, here's a big word. Perpendicular. What does it mean if a line is perpendicular to another line? Perpendicular. What does that word mean? Explain that. You're right. What is that? Explain it in terms of angle measure. 90 degrees. There you go. If one line is perpendicular to another line, it forms a 90-degree angle. So, if a line is tangent to a circle, then that line is perpendicular to the radius. If that radius is drawn to the point of tangency. So you might have seen before I erased it. Here was the center of that circle, correct?
No.
That's the center. If I drew a radius from the center to that point of tangency, what does this theorem tell me about the angle formed by that radius and that line of that tangent line? 90 degrees, exactly. That's the theorem. Yeah. I'm going out on my own here.
If you try drawing a circle with that angle thing, does it make it into like a triangle? Not a triangle, like an hexagon. Yeah.
No, if
like an octagon.
it smooths it out for me. Pretty cool, huh?
Try spelling my name. I keep remembering every time we try putting a square around something, it would turn into like an octagon.
Sometimes it does, if it's a little teeny. So here's an example. The first part of your homework, matter of fact, I already passed it out. Look at your homework. Look at question 1. The directions are, what does it say? Determine if line AB is tangent. Do you see what I'm looking at?
Yeah.
Now there's a triangle there, right?
Yes.
So how do we do that?
Carefully.
Okay. Colton, say that louder. Which angle? Look at the, because angle A has to be 90 degrees, right? If it is 90 degrees, then the answer is yes, it is tangent. But how do we know that it looks like 90 degrees, right? Can we just say, well, it looks like it's 90, so it doesn't say, so we can't assume.
Why can't we do that? That would make our lives so much
Oh,
easier.
but that's what
How can we prove that a triangle is a right triangle, you guys? Does anybody know a theorem that involves right triangles? A very famous theorem that involves... What is it? Pythagorean theorem. We are going to have to use Pythagorean theorem here. Okay, here's an example. This is kind of like... well, it's kind of like the problems that we're going to do here in just a second. We're going to finish this example, then I'm going to help you with problem number 1. And then I'm going to give you about 20 minutes to finish the front side. And then we're going to do the next section of notes. By the time we're done, I think you'll have this whole thing finished. No homework! Right? No, this is it. This is all we're doing today. This little packet here. But there's only 19 or so questions on it.
18, 20.
20?
You even have all the sides.
So on this example here, we have all the sides of a triangle. If this is a right triangle, then in this case, segment CB is tangent because that would be a right angle. So if it satisfies the Pythagorean theorem, and the key word there, it has to satisfy the Pythagorean theorem. So just because there's 3 sides of a triangle that looks like a right triangle doesn't mean it is. Does 7 squared plus 12 squared really equal 14 squared? If it does, this is a right triangle. If 7 squared plus 12 squared does not equal 14 squared, what does that mean? It's not a right triangle. And what's the significance of this not being a right triangle? Then that is not a tangent line. Okay? We have to make sure that this is a right triangle. So, this is just something you do the arithmetic for. Does 7 squared plus 12 squared really equal 14 squared? No. 49 plus 144 is not 196. 193. It's close. So the Pythagorean theorem is not satisfied. Therefore, triangle ABC is not a right triangle. So CB is not a tangent line. Now, let's actually do one more quick example here because they're going to make you think a little bit more on some of these. So here, on this example, is line AC tangent. That's this line down here, or segment rather, is segment AC tangent. Yeah, we're going to have to do the theorem again. If we can show that angle C here is a right angle, if we can prove that, and then using that theorem we just talked about, then yeah, it'll be a tangent line. Yeah. Logan, say that a little louder. Hold on a second, guys. Listen up. Yeah, where does 6 come from?
3 plus 3 is 6, the radius, and the diameter.
Exactly. There's a couple on your worksheet that are like this, and they do this on purpose to make sure you're paying attention. You need to know the whole side here, from C to B. I've only told you that from here to here is 3. So what does that mean about from here to here? That's also 3. So you can't use 3 squared plus 8 squared equals 10 squared. It's got to be 6 squared plus 8 squared. And we've got to see, does that really equal 10 squared? Is that a true or is that a false statement? It is true. 6 squared is 36, 8 squared is 64, 10 squared is 100. 36 plus 64 really does equal 100. That's a true statement. What does that prove?
It proves that's right.
That proves that's a right angle right down there. And because this is a right angle, that proves that this radius is perpendicular to that line, making it a tangent line. So CA is...
I need to know I'm swimming to the front office.
Okay. So here's question 1. This one's a little tricky. Question 1 on your paper. Is this what it looks like, right?
No. Yeah, they're not going to both on the bottom.
There's a 9 right there.
Yeah.
Yeah,
That's a little weird.
There's a dot where?
On the yeah, right there.
And that's essentially what it looks like. Right?
Yeah.
Okay. They're making you think a little bit on this one, you guys. Yeah, this whole length here is 15 from here to here. You're right.
then would you find B first, and then you would go for it?
Well, think about how we did the other 2 problems. The other 2 problems, we have to know all 3 sides, and that's still true. We have to know all 3 sides of that triangle. Did you have an idea? Which one's 9? This one here? How do we know that? Okay, this is an important idea that you're going to have to use not only in this lesson, but next time's lesson, and I think the one after that. You need to listen carefully. Okay? You had the right idea. What is it called if you start in the middle of a circle and go to the outer edge? What's that called? A radius. Isn't the radius the same no matter where you are in a circle? So isn't this also a radius from here to here? You're going to have to use this idea over and over again in this unit. And they purposely do this to make you guys think a little bit. So from here to here is 9, then from here to here is also 9. Yeah, this whole thing is still 15 from here to here.
Plus 15 squared.
Now we have all 3 sides of this triangle. So what you have now, which one is supposedly going to be the hypotenuse? The 15. That's the largest. So you've got to check, does 9 squared plus 13 squared equal 15 squared?
Wait, why is that 13 squared?
Yeah, why is that? Because A is going to go across, and B is going to go across.
Yeah, it wouldn't be
And then C would be the no.
Wait. Everybody's talking at once. What's the question?
They think that 13 is C, but it's not.
Why is it not?
On a right triangle, you guys, the hypotenuse is the longest side. 15 is larger than 13.
We don't know if it's a right triangle yet.
So that's why we're seeing if does 9 squared plus 13 squared, does that equal 15 squared? That's what we're trying to see. Exactly. That's why we're claiming this is C. This is A, B, and that's C.
Hypotenuse is always the longest.
Hypotenuse is always the longest side. It has to be. That's not a true statement, though, is it? 9 squared is 81. 13 squared is 169. 15 squared is 225. Those don't add up. 81 plus 169, that doesn't equal 225. So what do we answer for question 1? The question is AB tangent? What's the answer? No, it's not. So just write no, or not tangent, or I don't know.
Not tangent.
You say 9. I want to do it in German. That's true. But if you do write it in German, you have to make sure it's written angrily, because doesn't German sound like an angry language? 9!
So, rushing orders.
Yeah. Just the front page.
Oh, you want to do it from
Do the front page.
So if they have a little line, does that mean that's the entire thing?
That's the entire.
Okay.
You can work together if you want to help each other out. Your answers are either going to be no, it's not tangent, or yes, it is tangent. That's what you're going to answer on this front page here.
So I'll remember to do all the side lengths, how happy the whole line like that.
So yeah, you just do the, see if it satisfies Pythagorean theorem. Hey guys, you might not be there yet, and if you're not, that's okay. Skip ahead to number 9 real quick. Number 9 is a different set of directions, you guys. You need to listen carefully to the directions. Now it says, the last part of the directions, it says, if a line appears to be tangent, then it is. So if you look at number 9, doesn't this line right here look like it's tangent?
Yeah.
So then according to the directions, we can assume that that's a right angle. We don't have to prove it. So now all we need to figure out is, what's that side of a right triangle? Now, if you already know two sides of a right triangle, you do Pythagorean theorem. Now, there was something missing. I don't think they had a 10.8 right there, did they? They did. They don't. All they had was from here to here is 7.2. But it's that whole idea. If from here to here is a radius and it's 10.8, then isn't from here to here also a radius? Then that's 10.8. Okay? 10.8 plus 7.2 is 18. So this entire length right here is 18. So which side of the triangle are we trying to find? If we're talking about A, B, and C, E, B or A, right? B or A. So I'm going to call this one B. Okay. Exactly. So the theorem is A squared plus B squared equals C squared. So 10.8 squared plus B squared is equal to 18 squared. And then you solve it. You subtract, or you square everything and you subtract it. This square root. Okay. Let's go ahead and finish this. I need you guys' help though. I don't have a calculator. What's 10.8 to the second power? Thank you. 116.64 plus b squared. Help me out again. 18 squared. 324.
And then
You subtract what from what? Okay. Subtract this on both sides. So b squared equals 207.36.
Square equals 14.4.
Square root that. And again, b equals 14.4. Okay? So if you're there, continue on to do 9, 10, 11, and 12, but you guys stop on 13. That's a new topic we haven't got to yet. So finish up through 12.
Problem method, too long.
Here's objective 2. You can't see that, can you? There it is. Here's objective 2.
Well, it's the radius still, so.
True.
And those are different. They're the same, but they are.
Draw the picture. Write the theorem. Come on, let's go. We got our 10:40. We have a half hour. I still want to have more time to work on this homework assignment, so let's get a move on.
Can you guys get a perfect drawing?
I can't make you as perfect as I am, sorry.
Can I help with your computer?
Perfection involved is everybody. Perfection involved. Good.
Do you need help writing this down?
I hope not.
Well, let's get writing.
We're all perfectly ourselves, okay?
That's true. As imperfect as that may be, you are perfectly right.
There is perfection in imperfection, so we are all except none.
That's his same one.
Yeah, and that's the importance of this theorem, you guys. Now it's time to listen. It's one thing to write a theorem down, but it's another thing entirely to understand what it's talking about. Okay? If I start from point A, are you guys watching up on the board? If I start from point A and go over to point B, that's a tangent line. Okay? If I start at the same point A and come down to point C, that's also a tangent line. What this theorem says is, if two lines are tangent and they start from the same point, then those two segments are congruent. So from A to C is the exact same length as from A to B. That's what the theorem is talking about. How do we know they're the same length? Because they come from the same point, point A, and a tangent to the circle. Okay? You're going to have to use this theorem on number 13. Here we go. This one you're going to have to be patient with. It takes a little bit of time.
Is this 13 or 16?
This is going to be number 13 right here. Got to erase some stuff.
Are we going to be doing this for the rest of the unit, where we like stop every 10 minutes to do?
I'm going to try my hardest. Okay,
If
so
we do that, that'd be like the most amazing.
this direction is important. It says lines which appear to be tangent are tangent. Isn't that what your directions say?
Yep.
In the directions, read through the directions. Find the perimeter.
Okay.
So we don't have to prove that they're tangent.
Polygons.
The point of the question, you guys. Broken in.
All right. Get it. Okay, we can try.
Here we go. Okay. First of all, what's a perimeter? If you don't even know what a perimeter is, this question's going to be kind of hard. What's a perimeter?
The outside is like the length.
Distance around the entire.
Yeah, it's adding up all of those distances around the outer edge. Okay? So listen. Well, let's let you move over here. You're too much of a distraction over there. So we know this entire length is 10.1. We know this entire length is 12.9. We don't know the other two lengths of this polygon, so we can't figure out the perimeter. Here's where we use the theorem. Right here, you guys. Let me do this in a different color. If I go from here to here, doesn't that look like it's tangent?
Yeah.
So we can assume that it is. Doesn't it also look like it's tangent from here to here? So what does that theorem say about if two lines come from the same point and they're both tangent lines? They're the same. If this is 7.2 from here to here, then what's this? 7.2. Now we know that entire length, yes?
So with the one below, we consider tangent, but we have no.
Be 12.9.
So that would be 12. Let's see. Let's see. If we add those two together, 6.2 and 7.2, 13.4. That's going to be 13.4 for that one. Now, this next part you have to kind of be clever about. Listen carefully. We already know the entire side right there. It's 10.1. Okay? But we're going to have to split this apart into its separate lengths. What's the length from here to here, and then the length from here to here?
6.2.
How do we know this is 6.2? Because that's 6.2. It came from the same point, they're both tangents, so that's 6.2. If the whole entire length is 10.1 and that portion of it is 6.2, Then you do 10.1 minus 6.2, and that's 3. That's 3.9. Now, if this little guy right here is 3.9, what's this little guy? 3.9. If you subtract 12.9 minus 3.9, you're going to get 9. So from here to here is 9. What does that mean about from here to here? It's 9, because it comes from the same point, so that's 9.
Why would you do that like that? Why would you find it?
So we had to find this length right here. In order to find this length, we had to find that length. To find that one, so we had to go all the way around. So 9 plus 7.2 is 16.2. Now we add them all up. Each complete side length, we have 13.4, and then we add 10.1, and then you add 12.9. And then finally you have the last one, which is 16.2, and that will give you the perimeter of the polygon. So what is it? 52.6. 52.6? That's what you got? That's what you got? 52? We'll go with that. 52.6. That's the perimeter. We added up all these. So number 14 is a lot like that. I think there's 2 more on the other page. Well, there's 1 more. Number 15 is like that. Okay, now, for right now, I'm going to skip over 16, 17, 18. I'm going to get to those in a second. Go to the very, very back page. Very last page. I'm going to help you get set up on these problems, but I'm going to expect you to finish. Can I borrow yours for a second? Thank you. So number 19 looks something like this. You have a center of the circle here. And then there's a point here, and that line comes there. That line comes there. We have that. And then we have 2x minus 7, and here we have x plus 2. And the directions here are the same. Assume that lines which appear to be tangent are. That looks like it's tangent, so we assume that it is. That looks like it's tangent, so we assume that it is.
Can I have Megan Hardy to attend us for checkout, please?
Yeah. Hold on a second, Megan. Let's finish this up real quick. So we have to use that exact same theorem. These 2 lines come from the same point. That's a tangent line. That's a tangent line. So what does that mean about these 2 segments?
2x minus 7 equals.
They are congruent. They equal each other. 2x minus 7 equals the other side, which is x plus 2. Now all you got to do is solve the equation. Number 20 is like this as well. Okay? So let's get started on some of the other ones here.